Hi everyone, welcome to part 2 of Geometry Lesson 2.2, Conditional Statements. We're going to start off with an example where you need to determine the truth value of a conditional. So let's take a look at that. In example 3, you need to determine if each conditional is true. If it's false, you need to give a counterexample. So part A says, if today is Sunday, then tomorrow is Monday. So think about if today were Sunday, would tomorrow be Monday? If it's true, you can just write true. If it's false, see if you can find a counterexample. In part B, it says, if an angle is obtuse, then it has a measure of 100 degrees. So see if we could have obtuse angles, and if we can, then do they have to be 100? Okay, so if that's true, you can just write true. If it's false, you can write down a counterexample. And finally, in part C, it says, if an odd number is divisible by 2, then 8 is a perfect square. So again, decide, can an odd number be divisible by 2? If it can, is 8 a perfect square? And perfect square means that like a number times itself equals this number. So like 4 is a perfect square because it's 2 times 2. And like 25 is a perfect square because it's 5 times 5. Okay, so pause the video, see if you can figure out the truth value for those statements, and then press play to check your answers. Okay, part A was true because when it is Sunday, the next day would be Monday. So A is true. Part B is false because angles can be obtuse, but they don't have to be 100 degrees. So my counterexample was 120 degrees, but you can pick any other obtuse measurement. So anything between 90 and 180, not including 90 and 180, and that isn't 100 degrees. So anything between there, because that will make the conclusion false, but the hypothesis will be true. And finally, in part C, odd numbers are not able to be divided by 2 evenly. So the hypothesis is false. So this statement is automatically true. I know it's weird to say that because if the hypothesis is false, why wouldn't it be false? But we can't say what would happen in a world where odd numbers are divisible by 2. We can't say what would happen then, so we would automatically just assume that it's true until we're given more information. I know it's weird, but that's how it works. So now we have a check it out question coming up next. In check it out number 3, we need to determine if the conditional is true. If it's false, give a counterexample. And our conditional statement says, if a number is odd, then it is divisible by 3. That means when I divide by 3, it's going to go in evenly, no matter what odd number I pick. Okay, so there's no decimal area at all when you divide it. So pause the video, see if you can come up with an answer, make sure it goes on your classwork Google Doc, and then press play to see what's next. A conditional statement can be negated. That means we're going to change its truth value. And basically, it's the same thing as just adding a not into the statement. Okay, so remember that statement I gave you that said, if I get an A on my test, my mother will be happy? Well, guess what? If I add nots into both the hypothesis and the conclusion, it will change the truth value. So if I do not get an A on my test, my mother will not be happy. Okay, that is how I would negate a conditional. Any statement can be negated though. For example, you could say, I am running, and then you could negate it by saying, I am not running. And the symbol that we would use for that is this little squiggly line. That means not in math language. Okay, so that little squiggly line means not. It's also the symbol for similar, so we do reuse it. But that's how you would write the symbol for it. And you'll see that used in this next slide where we talk about related conditional statements. Okay, so there are actually 4 different types of related conditional statements. The first type is the original conditional itself. If P, then Q. So for example, if I get an A on my test, then my mother is happy. The next type is a converse. So this is the statement formed by switching the hypothesis and conclusion. So you'll notice that I switched these two. So in the original conditional, it says, if I get an A on my test, then my mother is happy. So I'm going to switch them and say, if my mother is happy, then I get an A on my test. So I switch the pink statement with the blue statement, and that will create the converse. The next type is an inverse. This is where we negate both the hypothesis and conclusion. So I would add in the nots. So I would say, if I don't get an A on my test, then my mother is not happy. Notice I'm putting these in here. If I do not get an A, then my mother is not happy. Those are the things that I added in to create an inverse. The original conditional would not have those parenthetical things in there. Okay, I would not need the parentheses, obviously, if I was writing an inverse. I just wanted to make sure you could see the difference in what I added. So if I don't get an A, no parentheses, then my mother is not happy. Okay, again, no parentheses. Now the final type, let's take a look. Okay, the contrapositive is the long statement, and this is where you do both. You're going to both switch the order and add in the nots. So my original conditional was, if I get an A, my mother is happy. So I'm going to switch the order and add a not. If my mother is not happy, then I don't get an A on my test. Okay, so those are all the related conditionals we have. Now, there are a few ways that I remember how they are. Contrapositive is the long word, so that's where you do both things. Converse is a type of shoe, right? It's a name brand shoe, and you get really happy when you get them. So you're going to do a dance move where you flip the order of your feet. So fun dance move is where you switch your feet around. And inverse is the pretender brand. It is not the real name brand shoe. It is the pretender. So I'm adding nots to say it's pretender. Okay, let's take a look at an example of this. Okay, in example 4, they want you to write the converse, inverse, and contrapositive of the conditional, and then tell if each one is true or false. So it says, if an insect is a butterfly, then it has 4 wings. And just so you know, butterflies do have 4 wings. They're just hard to see, but they do have 4 wings. So see if you can do that. See if you can write a converse, inverse, and contrapositive, and then determine whether they are true or false. Okay, the converse would be where you switch the order. So if an insect has 4 wings, then it is a butterfly, and that is false. Other insects have 4 wings, like a dragonfly. Dragonflies have 4 wings. A moth would have 4 wings as well. The inverse would be where you're adding nots into the statements, and you keep it in the same order as the original. So if an insect is not a butterfly, then it does not have 4 wings. And again, that is false. And again, a counterexample might be a moth, or it might be a dragonfly. And finally, the contrapositive, you're going to switch the order and add the nots. So you can say, if an insect does not have 4 wings, then it is not a butterfly. And that is true. All healthy butterflies need 4 wings. So if you have an insect that does not have 4 wings, it is not a butterfly. So you have a check it out question coming up next. In check it out number 4, again, you have to write the converse, inverse, and contrapositive of the conditional statement. If an animal is a cat, then it has 4 paws, and again, you have to decide true or false for each conditional. So pause the video, do that on your Google Doc, and then press play to see the last thing we have to talk about. Okay, the last thing that we need to talk about is logically equivalent statements. Okay, these are conditional statements that are related that have the same truth value. Okay, so it's going to help you with that true and false thing, because with those nots added in and switching the order, sometimes it's not very clear whether something's true or false. So the original conditional and its contrapositive will always have the same truth value. If the original is true, the contrapositive will be true. The original is false, the contrapositive will be false. They are linked together. The converse and inverse are also logically equivalent. So if a converse is false, then the inverse is false. If the converse is true, the inverse is also going to be true. So this just helps you when you're trying to determine true or false, because sometimes all those knots and switching the order makes it hard. So that's it for this video. Make sure you contact me if you have any questions about anything, and don't forget to submit your classwork and do your homework.